So this is Kafka Skewer channel. Welcome back. We will continue to talk about the Kafka. What do I want with Kafka, right? So remember that we talked about throughput, latency, and now we will talk about availability. Okay, so understood a little bit how I can have a high availability for Kafka. We need to understand some basic concept and configuration on the Kafka side. Yeah, this is a string here. Well, because this I need to put this configuration here because I forgot. Sorry, guys. Okay, so let's continue here a little bit to understand some things that's very important. If you want your Kafka stay with all the Kafka brokers continues to work good and work well, we need to take and care about, for example, unclean leader election enable. It is a kind of configuration that you can do from the Kafka, from the broker side, what this basic will do, right? Because the default for this configuration is false, but we can enable. But if you enable this kind of configuration, keep in mind the Kafka, he will basically, how I can explain. So let's go to the here. Okay, so we have three brokers here, and for the brokers you have the in-sync replica, right? The in-sync replica, the ISR. So basically, Kafka will try to do that something when you configure the unclean leader election. This will make leader election happen more quickly, which increase the overall availability, which means the Kafka do not will waiting, for example, to the partition, because you have three partitions here, for example. Actually, we have the leader, the partition, and the other guys is the follower, right? So if the leader go down for some reason, Kafka can elect a new leader without in sync, which means this could be provoke some losing messages, because the partitions now is the new leader and do not have all the messages that we have here in the old leader. So this is something that you need to care about and need to make sure, because here, guys, the focus, the goal for the Kafka availability, right? Another option is the min.insync replicas, right? Equal 1. I'm not sure if the default is 1, but I mean, we need to check in the documentation, but I mean, you can configure the min.insync replica equal 1. This way, Kafka or your producer, for example, you have a producer here, and if your producer put ACK equal all, for example, doesn't matter, because your min.insync replica is 1, which means producer will waiting, because the all, he will look into all of the min.insync replica, but because the min.insync replica equal 1, so producer will produce the messages only to the leader, and the producer will produce a message to the leader, wait until the message is committed, and go to the next messages, right? Remember, if you put 2, so producer needs to produce it to the first one, wait until the message is committed to the second partitions, or which means the replica, and so he can continue to produce more messages. So basically, this is the current configuration, because remember, again, the availability here, that we need to care about. So if you have a min.insync replica equal 2 here, right? If and 2 brokers growing down, I mean, producer will try to produce messages on the leader, but the leader do not have any another replica, and this will you start to see some problems, and producer cannot produce more because don't have enough replicas to produce more messages. So this is why we can decrease the min.insync replica equal 1, because we don't care to durability here, but the important is to keep Kafka working on, right? And the same to act, right? And this is a kind of configuration that you can do for the producer side. Another configuration is important here is the num.recovery.threads.per.data.dir. Remember, when you have a Kafka, perhaps you would like to put more partitions because this can increase the throughput. But remember, more partitions, you lead with more threads and more replicas between brokers. So if you have a bunch of replicas between brokers, perhaps you need to increase the number of brokers. Instead of using only 3 brokers, you can increase it 2 times. I mean 6 brokers, for example. This is a number 2. Okay, so let's continue. So because when you this guy here, no recovery.threads.per.data.dir, here the default nowadays is 2. You can talk to Kafka. Okay, Kafka, you now have like, I mean, 10 threads per. If you have it's normal in logdir, you can have a data1, data dir1, and data dir2. Remember in the throughput, right? When you want to have a high throughput, one of the tricks is to have more than one data dir, which means more than one disks plugged in your Kafka, configuring your Kafka, because you can split between 2 different disks the time that the things it's the IOPS right in your data. But at the same time, you need to increase the number of recovered threads, and this 10 represents 10 per data dir. So if you have 2 data dirs, you have a 10 here and 10 here. What this means? This means your Kafka will when you start up your Kafka service, he will start up very quickly and fast, because you have 10 threads per data dir to fetch all the data, to check all the things, to synchronize between all the files. And yeah, sometimes this could be a good tuning, because we need Kafka. If it goes down, or if some reason someone shut down Kafka, he need to recover and back in again very quickly and fast. And if you don't have enough thread, you can see and wait a lot of time. If nowadays you need to wait a lot of time to your Kafka services stay healthy and available, perhaps you need to take a look on this parameter here. And this parameter from the service properties broker, right? Another parameter here that we can discuss is broker hack. What is broker hack? So guys, this is not any new thing, right? This is just the configuration on the Kafka side you can check. Sorry. So the broker hack, basically you declare each server brokers. Let's go here through on the 3 brokers, right? Let's imagine and each broker live in a different AZ1, AZ2, AZ3. So you can configure the broker hack. This broker replica 1, broker replica 2, broker hack, actually broker rack, right? Not a replica, sorry. So You put this configuration on the server properties broker rec equal az1, broker rec az2, broker rec az3. So now Kafka knows we have a 3 different rec, and if you have one topic here with 3 partitions, Kafka will split partitions and will take care to split between replicas, right? All the partitions and the replicas. Leaders and replicas, he tried to a group, and they tried to stay more health and safe and guarantee the fault tolerance between a different AZ, right? This is a good thing to you can care about, and you could be take a look for your Kafka configuration, right? So please review this configuration. Go to the Kafka documentation. Try to understand what this configuration is good or not, and try to do some tests in your environment, right? And another configuration is in the consumer side. The consumer side, the trick here is put allow value for session timeout, or perhaps to max pull records, because we don't want Kafka consumers, actually the consumers, right, stay waiting something happen, or maybe you have some problem with these consumers, and the consumer spend a lot of time to do not recover. So the session timeout, to put lower value for the session timeout, could be good to you. You have a max pull interval MES, right, or max pull interval, max pull records. Then another 2 parameters that's good to try to check and review, because if the Kafka consumer wait a lot of time to expire a session, so you have some consumers that don't don't do anything, right, and don't consume messages, and it's just waiting the session's time out. And you don't need to wait so much, because you want the consumers and producers in live working and producing consumer more fast, quickly. And this could be a problem and an issue. So if you want more, the consumers stay more time working on, you could be review this configuration on your consumer side, right? So this is the process, how the process works. In the streaming configuration, the number of standby replicas configuration should be, the default is 0, but you need to put 1 or more, the state storage, the state restoration, right? So you can change the configuration, the new standby replicas, some configuration you can review and put greater than 0. And this can help you in on the streaming process side, right? So this is one of the configuration to try to put your Kafka in the high availability and guarantee that Kafka will work and recover very quickly and fast. But yeah, you have another configurations, and perhaps I forgot something that is important or something new. Please, if you know, if you remember, if you can, put in the comments down below. And it's a pleasure. It's a good to change this knowledge to hear you guys. What do you think, and what your experience, if you have some experience, if you did in some tests or have some scenarios that you need to change the things, create more brokers. This could be a configuration that you perhaps, as I commented here, you need to add more brokers to your scenario, because this will rebalance your split workload between more brokers. In the end, the saturation of the brokers is not so higher, because you can split the workloads between more brokers, which means you don't have all the connections in only one brokers, right? So this is a kind of thing that you need to care about. So okay guys, I need to go, so see you later. If you have some questions, any indication or any new idea for a different theme or different video that we can provide to you, please comment here. See you, bye.